Welcome students for general principles and process of isolation of elements, part 6th. In this video, we shall be studying about extraction of aluminium and extraction of iron. Let us continue with a brief revision of metallurgical processes which you have already learned in the previous video. In this, students, from a given list of minerals, we are selecting a suitable mineral as an ore and followed by the concentration of the ore, which can be done by 4 different methods: hydraulic washing, magnetic separation, 4 flotation process and leaching process. Once the ore has been concentrated, extraction of metal can be done by 2 main steps. The first one is metal is converted to metallic oxide from the concentrated ore, followed by the second step is metallic oxide is converted to free metal. And for the first step, conversion of metal to metallic oxide, calcination and roasting method can be used, whereas for the conversion of metallic oxide to free metal, we can use hydrometallurgy, pyrometallurgy and electrometallurgy. Further refining of metal can be done by following methods, that is distillation, liquefaction, electrolytic refining, pooling method, zone refining, vapor phase refining and lastly chromatographic method. After the refining process, we obtain the pure metal. Let's study extraction of aluminium metal. Uses of aluminium. Aluminium is the most abundant metal on the planet Earth. Applications of aluminium. Aluminium can be used in manufacture of aluminium foils. It can even be used for making of utensils and in paint industry. For making of alloys such as duralumin, which has the property of the lightweight and resistant to corrosion. Let's continue. Minerals and ores of aluminium. Let's discuss various minerals first. The first mineral of aluminium is the bauxite, aluminium oxide dihydrate. Second is the cryolite, trisodium hexafluoroaluminate. Third mineral is the corundum with the formula Al2O3, that is aluminium oxide. Next mineral is diaspore, which is aluminium oxide monohydrate, and the last mineral is the China clay, which is aluminium oxide silica dihydrate. Among all these minerals, students, bauxite would be considered as an ore of the aluminium, and profitably we can extract aluminium metal from this bauxite ore. Now let us consider extraction of aluminium metal from bauxite ore, and the first step is the concentration of ore, which can be done by Bayer's process for red bauxite and Hall's process for red bauxite, and student Sparks process for white bauxite. In case of red bauxite, we are having iron as the impurity. So if the impurity is the iron, student, then we are using Bayer's process for the concentration or else the Hall's process for concentration. And if it is white bauxite, that is silica impurities would be present, then we are using Sper's process for the concentration of bauxite ore. And in this case, we shall be discussing about Hall's process for red bauxite containing iron impurities. Let's proceed with leaching of alumina from bauxite, which can be done by Hall's process. In this case, aluminium oxide dihydrate, which is present in bauxite ore, along with the impurities, student, namely the iron impurities. When it has been treated with a reagent as sodium carbonate prepared in the water, thus given as aqueous, then we get the formation of carbon dioxide vapors along with the water, and the main component is sodium meta-aluminate, that is NaAlO2. And the sodium meta-aluminate, students, it is water soluble, whereas the impurities won't get dissolved with this reagent, that is sodium carbonate, and hence impurities would be settled as a residue. Thus sodium meta-aluminate, which is soluble in the water, which can be very easily filtered off. And the next one, when sodium meta-aluminate filtrate has been treated with plenty of water in presence of carbon dioxide, student, it would be forming aluminium hydroxide, a white color precipitate, along with sodium carbonate. So sodium carbonate, student, it is water soluble now. So you can get only one precipitate of aluminium hydroxide. And in the next step, this aluminium hydroxide, which is obtained as a white precipitate, students, it is gradually heated. Then we get oxide form of aluminium, that is aluminium oxide with the liberation of water molecule. In this way, we are isolating aluminium oxide from the bauxite ore. Second step is extraction of the metal. During the concentration of aluminium metal from the bauxite ore, we are isolating aluminium oxide. Thus, first step won't be done. Directly we are proceeding with second step. In second step, reduction has to be done, student. Aluminium is extracted by electrometallurgy. In this case, electrolysis of the fused alumina, which is done by using Hall and Hurlet's process. Let us consider Hall and Hurlet's process for extraction of aluminium. In this case, student, we are using an electrolytic cell which is made up of iron tank, and inner lining of this iron tank consists of cathode, whereas right at the center we are placing a rod which is called as graphite anode. And the electrolytic solution, student, what we are using consists of alumina with a 2 to 8% and the addition of trisodium hexafluoroaluminate nearly 80 to 85% composition, and aluminium trifluoride nearly 5 to 7%, and lastly calcium fluoride 5 to 7% in the electrolytic mixture. Once we pass the electric current in this cell, we can observe the following chemical reactions. The first one, trisodium hexafluoroaluminate, it reversibly decomposes into sodium fluoride and aluminium fluoride. and this aluminium fluoride ionizes into aluminium cation and fluoride anion. Reaction at the cathode, aluminium cations get attracted towards the inner lining of the iron tank, which is made as the cathode. So aluminium ions gain 3 electrons from this cathode. As a result, they are getting reduced to aluminium metal. And the aluminium metal, students, it would be collected at the bottom of the electrolytic cell, and by using drain plug at one end of the electrolytic cell, it can be collected very easily. And the next one, reaction at anode, fluoride anion loses 1 electron towards the graphite anode, and this reaction is called as oxidation of fluoride anion to fluorine atom. So this one is a primary step. In the secondary step, both the fluorine atoms combine to form fluorine molecule. Even though fluorine molecule is liberated, and this fluorine molecule further reacts with aluminium oxide for the formation of aluminium fluoride with the liberation of oxygen vapors, and this oxygen, students, further reacts with the carbon of graphite rod. As a result, the product are carbon monoxide and carbon dioxide vapors. Considering the electrolytic cell, the oxygen which would be liberated at the anode rod, students, it would be reacting with the carbon material of the anode, thus forming carbon monoxide, and further this carbon monoxide can react with plenty of oxygen to form carbon dioxide molecule. In this way, we obtain molten aluminium at the bottom of the electrolytic cell, which can be easily drained out from one end of the electrolytic cell, whereas at the anode we can observe either the formation of carbon monoxide or else that of carbon dioxide vapors. In this way, student, for the formation of 1 kg of aluminium, it consumes nearly 0.5 kg of the carbon from the anode rod. Now let us continue with the third step, that is refining of aluminium metal. For this, student, we are using Hooke's electrolytic process, and in this case the cell consists of 3 fused layers. Bottom layer, which consists of impure aluminium, which is made as the anode, whereas the middle layer, student, it consists of a mixture of trisodium hexafluoroaluminate and barium fluoride, which is an electrolytic mixture, whereas the topmost layer of this fused layer consists of aluminium, which acts as a cathode. In this, students, movement of pure aluminium from the middle layer towards the top layer occurs, and the same amount of aluminium metal moves from bottom layer towards the middle layer, and all the impurities are left behind in the bottom layer. So in this case, always impurities remains at the bottom, whereas the pure metal aluminium, which is collected in the topmost layer. Now let us study about metallurgical processes involved in the extraction of iron. Iron metal can be used within railway sleepers and in the giant stores. It can be used in manufacture of pipes and in the construction purposes, making of various alloys such as steel. Next, students, we are having 3 different types of iron. The first one is the cast iron or pig iron. The second one is the wrought iron, and the third one is the steel. In case of cast iron, 4% of carbon which is present, whereas in the wrought iron it is lesser than 0.2%, and in case of steel it is in the range of 0.2 to 2%. Always cast iron would be hard in nature, but it is brittle. It can be very easily broken. Whereas student, wrought iron is nearly soft, and steel, which is neither soft nor a brittle substance. Wrought iron is the purest form of the iron, whereas cast iron is the impure form of iron. Let us consider various minerals and ores of iron. The first mineral is hematite, that is ferric oxide, and the second is the magnetite, triferric tetroxide. Third is limonite, ferric oxide trihydrate, and fourth iron pyrite, ferrous sulfide, and the last one siderite, which is ferrous carbonate. Among all these minerals of iron, hematite is considered as an ore of iron. So let us consider extraction of iron from hematite ore. And the first step, students, which is known to you, is the concentration of hematite ore. This would be carried by hydraulic washing. Hydraulic washing, student, it removes all the lighter gangue particles, that is impurities. Already in detail, the hydraulic washing method has been explained to you in the previous videos. So here, student, iron which is preferentially wetted by means of the oil, followed by the agitation, forming the fourth, and in the fourth we can observe the ore particles which can be concentrated to get the concentrated form of hematite ore. Moving to the next one, extraction method, which is the second step. In this case, student, first step is conversion of ore into respective oxide, and it can be done by using roasting method, and the roasting is done in a reverberatory furnace at a high temperature of about 1200 Kelvin, wherein ferrous oxide would be reacting with oxygen to form ferric oxide. So the conversion of iron from +2 oxidation state to +3 oxidation state occurs, and in this process of roasting, student, both sulfur and arsenic impurities are removed. Why? Because sulfur would be forming sulfur oxide, and arsenic would be forming arsenic oxide, which is in the gaseous form, gets easily eliminated. Thus we are having ferric oxide. Second method of extraction is the reduction of metallic oxide into free metal. For this we are using the pyrometallurgy, that is smelting process. In this case, reduction occurs in the blast furnace and we get iron metal. Ferric oxide is getting converted into iron metal, and for this, student, you can observe in the diagram we are using blast furnace, and the second diagram represents one of the blast furnace. Now let us understand working of blast furnace. In this case, student, the metallic oxide is ferric oxide. This is mixed with the coke material, which is nothing but the carbon, along with limestone, that is calcium carbonate. In the ratio metallic oxide 12, coke 5 and calcium carbonate 3. That is 12:5:3 ratio. Then student, in the adjoining diagram you can observe the blast furnace which is having the cup and cone arrangement. Right at the top of the blast furnace, if you observe, it is having a cup and the cone like arrangement, and the first reaction which occurs at the base of this blast furnace is carbon gets oxidized to form carbon monoxide at a temperature of about 2000 degrees Celsius, and this helps ferric oxide to react with carbon monoxide, which is formed in the first step to form iron along with the carbon dioxide. Thus student, the carbon monoxide which has been produced in the first step, it is acting as a reducing agent which reduces ferric oxide to iron metal and liberation of carbon dioxide vapors. And the next reaction, ferric oxide can even react with the coke material directly, that is the carbon at 900 degrees Celsius for the formation of elemental state iron with the liberation of carbon monoxide vapors. The calcium carbonate decomposes to form calcium oxide along with carbon dioxide vapors, and this calcium carbonate which has been produced, this further reacts with the silica, which is the impurity, to form calcium silicate at 1600 degrees Celsius. It is zone of combustion, whereas at the top, that is in the range of 900 to 1200 degrees Celsius, it is zone of reduction, wherein reduction of ferric oxide to iron metal occurs, and in between both these zones we can see the zone of slag formation, that is the calcium silicate which is produced in the range of 1500 to 1600 degrees Celsius. And student, the iron which is present in the molten state, it would be collected at the bottom of the blast furnace as an outlet, whereas one more outlet right above the outlet of the molten iron we can find at the bottom of the blast furnace itself. It is the outlet meant for the slag, that is calcium silicate, which has been produced. In this way students, we can isolate iron from ferric oxide by blast furnace. And the next one, extraction of iron from the hematite ore. We can have a brief summary of all the sequence of steps involved, that is right from the first one, hematite ore, which is concentrated by hydraulic washing. So we get concentrated ferric oxide, which is then extracted by roasting process, and we get roasted ferric oxide, and the roasted ferric oxide can be reduced by using blast furnace to form the cast iron. In this way student, we can extract the iron from the given hematite ore. Thank you students. In the next video, we shall be studying about extraction of the copper metal from its ore. Thank you.